as we welcome to the stage right now, our next is the founder and CEO of Girls Security, Lauren Buitta, and the federal consult partner of Kyndryl. Please welcome Eva Koca.
Hey, that was the most exciting introduction I've ever had in my life. First of all, thank you all for being here. Again, my name is Lauren Buitta. I'm the founder of Girls Security. I'm also the founder of a new initiative we have called All Secure X, which we'll talk a little bit more about. And I'm joined by one of the coolest people I know, a woman named Eva Koca, who I'll ask to introduce herself. Eva has seen things. That's the best way I know how to describe it. Her career has spanned so much of the technological development that we've seen over the last several decades. And so I really encourage those who have questions in the audience to pick her brain, because I think she'll be very reassuring at a time when things feel a little weird, is sort of the best way to describe it in AI. So let me just tell you a little bit about Girls Security. We are a national nonprofit, and we focus primarily on supporting girls and young women finding pathways into national security. We also produce resources and tools that serve everyone. So our principled approach is that there are alternative ways of thinking about national security that we've not yet explored. And that because girls and women are confronted often with different types of security threats, they have a unique experience and insight that they can lend to how we think about developing solutions to things like AI and quantum computing. So it's a very principled approach. And All Secure is a new initiative, as I said. So we're actually building technical solutions to the workforce challenges we're seeing, because our program actually starts at the high school level and we work up. So before I hand it over to Eva, I'll just give you a little insight into how we're thinking about AI, because again, we're designing workforce programs for the high school level. As you may know, especially if you're a parent or caregiver to a child, AI is largely disruptive at the moment. The educators we work with are really struggling with how to incorporate competencies into K through 12 education. So that is why at Girls Security, we actually focus on building human intelligence and sort of AI as an after part. And what I mean by intelligence is we sort of democratize the intelligence field to teach primarily critical thinking for innovation, ethical decision making, and metacognition. And once young people in our program have gone through something like that, they have sort of foundational skills to tackle AI. And we really do believe that building human intelligence to match a future shaped by AI is where a lot of emphasis is not being placed, but where we think there's a really significant opportunity. So before we get into it with Eva too, I want to turn it over to Eva to introduce herself and share more about what she's doing with one of our partners.
Thank you, Lauren. Eva Koca. I actually have been in technology around computers for many, many, many years. I started when I was 16 years old. I got a summer job through my dad. I'm a Nepo baby from that standpoint. So I ended up working actually my first summer job in a large data center. I walked into this big mainframe room, raised floors, look around, and with the ignorance of the 16-year-old, yeah, I can do this. So I did. I know I started to do it, and I mean that it became kind of a place where I pretty much did a variety of my summer jobs. I ended up studying initially 1 year mathematics. I'm originally from Czechoslovakia, now it's actually Czechia, Czech Republic, and then ended up at the Technical University of Prague, which is their main technical university. It's also the third oldest technical university in Europe. Interesting enough, I actually found out somewhere up there, 1336, there is a booth which has different embassies, and there are actually people from my old school as well. So it was actually very random that I found out they were here today. But again, great school. My educational background was really kind of very heavy in science, engineering, math, and so on. So later on, when I came to United States, I was actually very lucky. I ended up in Silicon Valley and worked for a company which was actually the first one who put internet into the commercial space. So this company used to be a company called Wollongong Group. So I was part of the Wollongong R&D. And from there, I did more coding. I did actually lots of C coding, but one day I got bored because you write million lines of codes, and now what next? So I got more into managing, architecting, building solutions, doing all kinds of different things. And these days, actually, I am with a company called Kyndryl. I'm not sure if you heard about it, but many of you heard about IBM probably, correct? Yeah, so yeah, IBM about 3 years ago ended up is the selling part of their so-called global infrastructure services and build this new company called Kyndryl. So long time ago in school, I am back occasionally dealing with mainframes because we actually run the infrastructure for about 60% of the top 100 companies. So we are actually very quietly running all these very amazing computational infrastructures all over the world, and we probably do it pretty well because nobody hears about us having any problems or causing problems for our clients. And back in school, interesting enough, we were actually studying some of the foundations that were for AI. I mean, we were talking about inference engines. We were talking about a variety of like neural networks and stuff like that. Lots of mathematics, lots of probability statistics. But our issue was we didn't have the computational power to do it really in scale. So now, when I'm at Kyndryl, whole different thing. So if you have time, look it up. We have right now a very interesting product called Kyndryl Bridge. And Kyndryl Bridge actually, we have AI running against about 30 years of data that we collected through the years. We can do lots of predictive analytics, help our clients to look what needs to happen in the future. And I believe the last numbers was we actually, in like a couple of years, we saved about 3 billion to our clients. We do about 12 million different predictive kind of cases telling our clients on a monthly basis, like, hey, there's an opportunity to improve something, there's an opportunity to do something differently, and we have about 1,200 clients for that all over the world. But otherwise, yeah, we are a publicly traded company, about 18 billion, and about 80,000 people all over the world. So it's lots of exciting stuff happening up there, and yeah, I see it like I made the full loop. I mean, you know, from starting somewhere and then getting back to kind of really being able to do AI in scale. That's a whole different ballpark. Yeah.
Eva's she's seen everything. She made AI fetch before it was cool.
Yeah.
One of the things I wanted to touch upon, I think probably everyone has heard over the course of, you'll hear it over the next few days, is how disruptive AI has been to the workforce, with a lot of the narrative being that we won't need entry-level jobs. And so that's a sort of jarring, I think, reality for a lot of people, and certainly for an organization like ours that focuses on building the workforce. It's difficult to find, I think, those kind of key reassuring insights and frameworks that can help guide whether you as an individual who are a job seeker or as an organization that serves populations that don't have access to technology. And I just wonder, like, what is a key insight, having worked on AI, cyber, quantum, that you would share to an audience of people who are interested in how they should be thinking about navigating artificial intelligence?
Yeah.
Like, what's the nugget, Eva? What's the nugget?
AI means many things to different people. And it really kind of depends what your skills are or where do you want to start. I mean, maybe you don't have necessary goal to do some sort of high-level computing on some sort of whatever, ultra-high-speed computers. That may not necessarily be your thing to do any kind of like coding programming, but there are lots of things that people need to understand. Why are we really doing AI? Or what does AI mean? Just because somebody comes in and says, we are doing AI. There are 5 things that you always need to think about. And even if you build potentially entry-level people, helping to build use cases. Use case ask you, what are you trying to do? Why are you trying to do it? Where, who, and sorry, not who. Who, when, what, where, why, and when. So your 5 W's. That's something that people who are interested in, let's say, coming to AI, potentially some sort of analyst or data analyst, you don't have to have very kind of highly data-oriented skills to start there. But being able to start as a potential as an analyst and building these kind of use cases, that's absolutely must. The other thing is lots of work needs to be done around data. And people, right now we are talking about training the AI engines and making sure that you really have data that you can trust. Because if you start with data that you cannot really trust, it's like, sorry, garbage in, garbage out. But you need to be able to trust the data. So there's lots of room for people being able to curate the data, worry about data quality, worry about who really owns the data. Do you trust the data? So when I talk about, let's say, us, Kyndryl, having these 30 years of data that we use for our AI engine, we trust the data because we had it all the time. It didn't come magically from somewhere. So we really do trust the data a lot. So activities like that. The other thing is, I mean, I have been, again, in this technology field for a very long time. Sometimes AI seems like this next shiny object. But before we throw something into so-called AI, again, there is lots of stuff that needs to be done with just basic automation. So automating certain activities. And if you look at it industry-wise, probably 60-70% of whatever new things are happening, trends, it's really around the automation. That, let's say, in your business, you can speed up the way how you work. You can make more efficient decisions. And that's really only automation. You don't need the AI engines at the end to do it. So again, there is lots of room. So if you want to get into really high-end AI, potentially start with the automation and build up.
Thank you, Eva.
Yeah.
We have like 3 minutes left, and I want to leave room for any like burning questions from anyone. Don't be afraid. Anybody have a question? I know you have a question. Well, I think what we can do is, I think with the 3 minutes we have left, I think it's important to sort of reset our understanding that the weight of AI feels very heavy now. At Girl Security, we see a very effective approach with focusing on intelligence as a competency. So for those of you who are stewarding young people, I don't think there is a rush to put AI in young people's hands, but to really think about skill building, their foundational skills. Because as Eva and I were talking about, the next shiny object is quantum computing. As you know, it's the year of quantum computing, and we can sort of feel the pressure that's building on making quantum computing a workforce need. And the reality is that we have to have critical conversations like this to think about what are we doing to help build the workforce that's going to be rapidly changing, and what are the appropriate approaches that we need. And these types of intergenerational exchanges are really critical to Girl Security because these are multi-generational issues. So we're going to hang on for the last few moments after this. But do you have a closing thought on quantum computing? I know this is not a quantum computing, but there will be one next year. So what is your closing thought on quantum?
There's lots of theoretical stuff being done around quantum computing, but in its foundational way, we are suddenly dealing with more than bits and bytes. Yes or no, we are dealing with qubits. So let's say suddenly if you are computing on something which is 4 qubits, instead of bit and byte, you can have 2 to 4 type of possibilities. So suddenly the amount of instructions, the amount of computation that you can do in a given amount of time is significantly bigger. So you suddenly, instead from this, you can deal with that much. Outcomes are that suddenly, once this becomes really reality, our encryption, for example, when you go to bank or interact with your bank, the way how your communication is encrypted, that could become significantly faster to break. So we will need to figure out something like that, but we will have more computational power to worry about DNAs, to worry about how our proteins are folded, modeling that stuff. I mean, there are definitely lots of applications that could be done much faster way with the quantum computing. But let's say we could do the same computations with the current computers that we have, except that would take forever. That would take thousands of years or something. Now we have potentially technology that would do it much faster. And going back I was working on the mainframe, which could do very little type of calculations in a very, very long time. Now in my cell phone, I can do so much more. So Right now we have all these very large quantum computers in pretty much research type of setting. I'm pretty sure that 20 years from now, yeah.
As one DARPA scientist told me, it could be the most disruptive thing ever, or it could be absolutely nothing.
Yeah.
And that sort of feels like where we are with AI too. So
probably.
Thank you so much, and thank you all for joining us. We'll hang out for questions afterwards.
Thank you.
Thank you so much, the founder and CEO of Girls Security, Lauren Buitta, and Federal Consult Partner of Kyndryl, Eva Koca. Thank you so much.